Question 5 is on sequences, and part A asks us to identify the arithmetic and geometric sequences from this table here. So arithmetic sequence is one which has a constant difference. So we need to look at each of these sequences and look at the difference between them, and hopefully you can see that in sequence W, the common difference is 10. It increases by 10 each time, so the arithmetic is Wn. In part 2, we're looking for the geometric, which has a common ratio. So if we take two consecutive numbers and divide them, that ratio stays the same. And we can see, looking at Un, that if we divide 20 by 10, we get 2. If we divide 40 by 20, we get 2, etc., etc. So the geometric sequence is Un. And we can also note, just looking ahead to the next question, that in the geometric sequence, the common ratio r is 2, and likewise in the arithmetic sequence, the common difference equals 10. Part 2 then asks us to find the exact value of the 11th term for the geometric sequence, and we can do that using the formula. So we know that Un equals U1r to the n minus 1. So here, if we want to find the 11th number, U11 is going to be equal to U1, the first term, which is 10, multiplied by r, which we identified on the previous one, the common ratio, equals 10 to the power n minus 1. And if we do that, we end up with an answer of 10,240. Part C says find the sum of the first 20 terms of the arithmetic sequence. So what we're in effect being asked to find here is S20. So we can use the formula for the sum of a arithmetic sequence. So the general formula, the easiest one to work out here, is n over 2 U1 plus n minus 1 times d. So in the context of this question, n is the first 20 terms, so that's going to be 20 over 2 multiplied by 2 times the first term, and the first term we said was 10, plus n minus 1, so if n is 20, that's going to be 19, multiplied by d, which we said was the common difference earlier, which is 10. So if we multiply that all out, we end up with an answer of 2,100.